Hi everyone, today we will be presenting on the application of vector calculus in the field of navigation and GPS. Our group members are Kimberly, Huishan, Xiaoling, Ruben, and me, Huishan. Here's the overviews of the topic we'll cover. Let's begin with the introduction. Navigation and GPS technology have revolutionized modern travel and transportation by ensuring accurate and efficient movement across diverse terrains. At the core of these systems lies vector calculus, which provides essential mathematical tools for interpreting spatial relationships and also enables precise comprehensions of positions, direction, and motion. Vector calculus in navigation and GPS is significant in determining positions, optimizing travel routes, and also ensuring real-time accuracy. Furthermore, it supports advancements in aviation and marine navigation as well as cutting-edge technologies like autonomous vehicles and drone systems.
Now I'd like to talk about vector calculus concept in the application. The first concept is vector in 3D space. In navigation, vectors are used to describe position, movements, and force in 3D space. The first vector is position vector, which indicate the location of a point relative to an origin. The next vector is velocity vectors, which show how fast and in what direction something is moving. And the third vector is acceleration vector, which represent how the speed or direction of an object change over time. And the last vector is unit vector, which define direction without magnitude, and all of the formula of vectors are shown below. Next, the second concept is gradient. Gradient is a vector operator that indicates the direction and rate of change in a scalar field. And the third concept is divergence. Divergence is used to measure how much a vector field spread out or converge at a point. In navigation and GPS, it is used for signal analysis where signals spread out or concentrate. And the last concept is line integral. Line integrals calculate quantities along a curve, and for navigation, it usually used to calculate the most efficient path, and the formula is shown below.
Next, I would like to briefly discuss the application of vector calculus in real-world technology, particularly focusing on GPS technology and airplane navigation system. Let's start with GPS. GPS relies heavily on vector calculus to provide accurate positioning. By using signals from a network of satellites, a GPS receiver calculates its distance from each satellite by measuring the time it takes for signals to travel. These distances, combined with satellite positions represented as points in 3D space, enable the receiver to determine its exact location using trilateration. Vectors also play a crucial role in calculating velocity and direction, allowing GPS to monitor speeds, track vehicles, and plan optimal routes. Next is the airplane navigation system. Pilots use a wind triangle, a form of vector analysis for dead reckoning. By combining the plan's airspeed with wind speed and direction, vectors help calculate ground speed and wind correction angles, ensuring accurate navigation. This is essential for maintaining a desired flight path, estimating fuel consumption, and planning timely arrivals.
Next, I will explain the impact and benefits. GPS systems benefit from precise calculations of positions in 3D space by using signal from at least 3 satellites. Through vector calculus, operations like gradients and divergence analyze satellite data to determine latitude, longitude, and altitude while correcting error caused by atmospheric interference. Another benefit is creating smooth, optimal, and shorter paths. Vector calculus help avoid sudden directional changes, ensuring safety in scenarios like aviation, where smooth curves are preferred. Then, gradient aid in route optimizations, and line integral determine the shorter path over curved surfaces, reducing travel distance. Lastly, GPS predict the future positions of moving objects using velocity and acceleration. For instance, aviation systems calculate aircraft trajectory and use integrations and differentiation to maintain safe distance between.
At the end, I want to conclude that vector calculus is the transformative tool for GPS and navigation, which enable accurate position determination, route optimization, and error correction. Key principles such as gradient, divergence, and line integral enable precise calculation and effective problem solving in diverse scenarios. Advanced technological can address challenges such as computational complexity and resource requirement. Vector calculus underpin reliable and efficient navigation, revolutionizes transportation, logistics, and daily navigation tools. Thank you.